Okay. What set builder notation is it's basically a formal way to represent here's all of the inputs or the domain. Here's all the outputs or the range. We can represent it informally. And one thing we need to acknowledge that was implied when we wrote this down, you guys will notice in the definition for this I was using this word set. That actually is an official math term. In math, a set is a collection of things that all go together. Usually, since it's math, it's going to be a collection of numbers. So all of the inputs go together because they're all inputs, so we would call them a set. The reason I mention that is because whenever we're writing about the inputs or the domain or the outputs or the range, there's actually a symbol that goes with this term to say, hey, these things all go together. And that symbol is curly brackets. So informally, I could do something like this. And I'm in my top flap. 2, 4, 6, 8, ... What does ... mean?
It keeps continuing.
It keeps going. So this would tell you it keeps going forever, right?
Yes, correct.
So, yeah, those curly brackets are an actual math symbol. They need to be there. They are the symbol that says, hey, these things are set. They belong together.
How many helps are in the curly bracket?
Here, I could put one bigger. I'll do it off to the side. Draw you a giant one so you can see how to do it. So you kind of curve around and then come out to a point and then back down.
Oh.
Same thing on the other side. It's harder to see them when you're writing it small.
And those are called curly brackets?
I call them curly brackets.
So, but like, should we like write down?
Well, you just need to know that if you're talking about domain or range, you need those there because that's the math. It's an actual math symbol. That's the math symbol that says, hey, these things all go together. They are a set.
Is this inside
So this would be, this could be inputs or outputs. These ones probably more likely outputs. So this might be a way of saying, hey, I've got a bunch of outputs. They start at 2, and then they're going up by 2 each time. Here's another one. Zero, 1, 2. Again, I've got the curly brackets, so I know those all go together, right?
Yeah.
That could potentially be another set of inputs or outputs. Here's another one. Just getting you guys thinking about the different ways you could write this. Sometimes you might see inequality symbols in there. And that comes back to some of our discrete versus continuous that we've been talking about. If you see something like this, 2, 4, 6, 8, are you going to think discrete or continuous? Probably discrete because we're not including odd numbers there, right?
Yeah, right.
If you see this, is your first thought going to be discrete or continuous? Discrete, because what do you notice about these numbers? They're all whole numbers. But if you see this is x is greater than or equal to 0. So this means anything 0 or bigger. What are you going to think?
continuous.
Yeah, because you could have 1.3 or 1.03 or 1.003. Those are all bigger than 0, right? But there's a bunch of different things in there. So this you would think continuous. So you could kind of start to see this whole discrete versus continuous thing come up. This is informal notation. I'm going to close this just for a minute so we can label this, just so we remember that this is informal notation, just to get you thinking about if I say what is the domain or what is the range, what does it look like? It looks like a list of numbers. So this would be our informal notation. Sometimes this is called roster notation. It is still notation. I'm using the curly brackets, so I'm using some math notation in there, but it's very informal. So roster notation is what that's usually called. Now, what we're after is the more formal notation, because the more formal notation gives us more information about our domain and our range. And if we get more information, that's better. More information means we can do more things, right?
Yep.
So this bottom flap is going to be where we're going to put our set builder notation. That was a better. There we go. We're going to take the things in this top flap, and we are going to turn them into set builder notation on the bottom flap. So you guys can kind of see, here's the list of numbers that I'm starting with, and here's what it looks like in the formal notation to help you guys make the connection and understand how the notation works. First of all, we need an outline for what set builder notation looks like. It does follow a generic outline. The outline kind of looks like this. I still have my curly brackets because these are still a set of numbers. So those curly brackets are still there. If I'm going to put this in formal notation, the outline looks like this. Inside the curly brackets, I'll start off with a name. Usually it's a variable name for whatever I'm describing. And then you'll see this vertical bar. And on the other side of that bar, you'll see all of the conditions or restrictions. So like on our first one, our restriction is that we're only doing even numbers, right? So that's over here is kind of where you list it. So this is what I'm calling it, and this is kind of the rules for what numbers are included with that group of numbers. If you were going to say this out loud, you would say that it is the name, this bar, you would say such that, and then whatever happens. Yeah, so if you're saying it out loud, like if you were reading it out loud for somebody, when you hit that bar, you would say such that. So in a minute, this will make more sense when we actually fill numbers into it, but this is just the general outline. Before we can fill numbers into this, though, we need to talk about something that goes over here on the conditions or the restrictions side. There are a bunch of different types of numbers, and these three examples are intentionally picked to give you some examples of three different types of numbers. What's the difference between the first set of numbers and the second set of numbers?
1 times by 2, 1 times by 1.
What else?
Negative, 1 positive.
Yeah. So the bottom, these are just positive, even numbers. Down here, now I've got more numbers. I've also got negatives, right? So that makes this a different type of numbers. Hold on to your thought. We're probably going there anyway. What's the difference between the second one and the third one as far as what's included?
Could be decimals.
The third one can be decimals and positive.
Yeah. So this is only positive again, but the difference between this and the first two is that now I can have decimals and fractions, right? Because there are a lot of things that are not whole numbers, but they're still bigger than what? Sam, question?
It's discrete versus continuous.
The similarities or differences.
Discrete versus continuous.
Yeah, you're right. We've also got a discrete versus continuous thing going on here too. And an inequality symbol, that's kind of your giveaway really for discrete versus continuous. Because continuous, if you put an inequality symbol, it's going to catch everything past that. But yeah, that should be acknowledged, is that we do have some discrete and continuous. We also have different types of numbers though. We've got fractions and decimals, we've got negatives, we've got only positives. So if we're going to talk about conditions over here, we need to have the math vocabulary to talk about those different types of numbers. That's what this little diagram is that I gave you. This is a little cheat sheet with all of the different types of numbers that are out there in the math world. Some of you guys already know about some of these. Some of you guys maybe need to kind of get up to speed on the vocab, but that's why I gave this to you, so that we could talk about this, so that you can use these words when you're talking about conditions or restrictions. What types of numbers are part of the inputs? What types of numbers are part of the outputs? Question?
You said like the third one was continuous.
You are going to need to know these in order to use set builder notation.
For the top flap.
Oh, yeah, the top flap, we don't have anything else over there.
No, on the right. Yeah, that one. Yeah, you said that was continuous, but it doesn't include negatives.
Yeah. I mean, this can take on a lot of different formats. And that's the thing with informal notation is that it's informal, so there's kind of some gray area in there. And that's exactly why we want set builder notation, because it lets us get more specific. Okay, these guys, so that we